All right, good morning. Today we're going to talk a little bit about continental drift. Continental drift? This is the 13th assignment you've had. And you're probably thinking, what the heck is continental drift? Well, the thing that the state wants us to do is analyze and interpret data on the distribution of fossils, so where fossils have been spread out all over the earth, and rocks, and continental shapes. Remember, a continent, large piece of land above sea level, continental shapes, and seafloor structures to provide evidence of the past plate motions. All right, so we've got plates, and we've got evidence that they're moving. These continents, this is kind of weird. Yeah, maybe, says Mr. Jensen. Nope, says Mrs. Adkins. I'm lost, says Mr. Wagner. Well, let's help these guys out and see what's going on. 500 years ago, the sea voyages of Columbus and other explorers changed the map of the world. The continents of Europe and Asia and Africa were already known to the map makers. Soon map makers were also showing the outlines of the continents of North and South America. Looking at these worlds, maps, many people wondered why the coasts of several continents matched so neatly. I highlighted that for us because that's a very important part. South America looks like it fits into Africa. North America looks like it fits right along Africa and Europe. Looking at these world maps, many people wondered why the coasts of several continents matched so neatly. For example, the coasts of Africa and South America look as if they fit together like a jigsaw puzzle piece. In the 1700s, geologists, or people that study the earth as a geologist, thought that the countries, or the continents, had always remained in the same place. But early in the 1900s, one scientist began to think that the continents could have once been joined in one big single landmass. In 1910, a young German scientist named Alfred Wagner became curious about the relationship of the continents. He hypothesized that Earth's continents had moved. That was his educated guess. Highlighted, it says, Wagner's hypothesis was that all the continents were once joined together in a single landmass and have since drifted apart. Wagner's idea that the continents slowly moved over Earth's surface became known as continental drift. According to Wagner, the continents drifted together to form the supercontinent Pangaea. Pangaea means all lands. All of North America, South America, Africa, Europe, Asia, Antarctica, Australia, all made a supercontinent called Pangaea, which means all lands. And the belief is that maybe over time, South America drifted apart from Africa, Africa drifted up, North America drifted apart, Australia drifted down. Now we have a map of the world that looks like this. South America, North America, apart from Africa, Europe, Asia, Australia, Antarctica's down here. But maybe they were all together. They do kind of look like puzzle pieces that could fit together in a weird sense. Wagner gathered evidence from different scientific fields to support his ideas about continental drift. He studied land features, like mountains. He studied fossils, bones buried deep within the earth, and evidence of climate change. Places that were once warm are now cold, or were once cold, now warm. In 1915, Wagner published his evidence for continental drift in a book called The Origin of Continents and Oceans. What was his evidence from land features? As shown in figure 12 above, Mountains and other features on the continents provided evidence for continental drift. For example, when Wagner pieced together maps of Africa and South America, he noticed that mountain ranges on both continents lined up. He noticed that now once again, I'm going to show you up here the area where the continents lined up with mountain ranges. He noticed that European coal fields matched up with coal fields in North America. These here. Interesting. What about from fossil? Evidence from fossils. Wagner also used fossils to support his argument for continental drift. Remember, a fossil is any trace of an ancient organism, a living creature, that has been preserved in rock. For example, Glossopteris was a fern-like plant that lived 250 million years ago, supposedly. Glossopteris fossils have been found in rocks in Africa, South America, Australia, India, and Antarctica. The occurrence of Glossopteris on these widely separated land masses convinced Wagner that Pangaea had existed. Other examples included fossils of the freshwater reptiles, the Mesosaurus and Lystrosaurus. These fossils have been found in places now separated by oceans. Neither reptile could have swum great distances across salt water, but Wagner inferred that these reptiles lived on a single landmass that had since split apart. Looking at these things, they don't look like big swimmers or ones that could have swam all the way across the Atlantic Ocean, especially if it was a male and a female to reproduce on certain areas. Not probably the best date you could ever go on is to swim across an ocean, being that you need water and food and you can't drink salt water. So not a bad idea, especially when you fit this little part into this little part. These areas where they found these fossils seem to line up beautifully. What about evidence from climate? Wagner used evidence of climate change to support his hypothesis. As a continent moves toward the equator, its climate becomes warmer. As a continent moves toward the poles, its climate becomes colder. But the continent carries with it the fossils and rocks that formed at its previous locations. For example, fossils of tropical plants are found on Spitsbergen, an island in the Arctic Ocean. The Arctic Ocean is cold. When these plants lived, possibly 300 million years ago, the island must have had a warm and mild climate. According to Wagner, Spitsbergen must have been located closer to the equator. He's thinking, why in the world would these warm plants be in the Arctic Ocean? Geologists found evidence that when it was warm in Spitsbergen, the climate was much colder in South Africa. Deep scratches in rocks showed that continental glaciers once covered South Africa. Continental glaciers are thick layers of ice that cover hundreds of thousands of square kilometers. But the climate of South Africa is much too mild today for continental glaciers to form, meaning it's not cold enough. Wagner concluded that when Pangaea existed, South Africa was much closer to the South Pole. According to Wagner, the climates of Spitsbergen and South Africa changed because these land masses had moved. His claim is that all the Earth's land was once joined together and has moved apart. Below, I would like you to put in, what are the 3 types of evidence that Wagner used to support this claim? Now, his reason for it, he doesn't have yet. He didn't really know the reason why this happened, but he did have a claim and he did state some evidence. Go ahead and on the next area, fill in the 3 types of evidence Wagner used.